is an export garments factory, which is doing all the jobs right from cutting to stitching to final finishing touches like embroideries, putting buttons, appliques, washing and ironing within itself. All these jobs are done at large scale with the help of huge machines. How do you think these machines are being run? Manually? Of course not. Then, what is running the machines? Well, you all know the answer. It is the electricity. Electricity has become one of our prime needs. Where does this electricity come from? There are huge electric generators which are producing electricity for us commercially. Not only this, we have got small electric generators that generate electricity for our homes, offices and shops during emergency needs. Today's class is focusing upon these electric generators.
Dear students, आज ਅਸੀਂ ਇਲੈਕਟ੍ਰਿਕ ਜਨਰੇਟਰਸ ਬਾਰੇ ਪੜ੍ਹਨ ਜਾ ਰਹੇ ਹਾਂ। ਅਸੀਂ ਸਾਰੇ ਹੀ ਇਹਨਾਂ ਨੂੰ ਦੇਖਦੇ ਵੀ ਹਾਂ ਅਤੇ ਵਰਤਦੇ ਵੀ ਹਾਂ, ਪਰ ਇਹਨਾਂ ਬਾਰੇ ਜ਼ਿਆਦਾ ਜਾਣਦੇ ਨਹੀਂ। ਆਓ ਇਹਨਾਂ ਬਾਰੇ ਜਾਣੀਏ ਵੀ। ਅੱਜ AC ਜਨਰੇਟਰਸ ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਭ ਦਾ ਸਵਾਗਤ ਹੈ। ਅੱਜ ਦਾ ਪਾਠ ਸ਼ੁਰੂ ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਅੱਜ ਦੇ ਪਾਠ ਦੇ ਲਰਨਿੰਗ ਆਬਜੈਕਟਿਵਸ ਜਾਣ ਲਈਏ।
On completion of this topic, learners will be able to define generator, discuss types of generators, describe construction of alternating current generator, describe working of alternating current generator, solve numerical problems on AC generator.
ਬੱਚਿਓ, ਪਿਛਲੇ ਪਾਠਾਂ ਰਾਹੀਂ ਤੁਸੀਂ ਹੁਣ ਤੱਕ ਇਲੈਕਟ੍ਰੋਮੈਗਨੈਟਿਕ ਇੰਡਕਸ਼ਨ ਬਾਰੇ ਕਾਫੀ ਕੁਝ ਜਾਣ ਚੁੱਕੇ ਹੋ। ਇਹ ਇੱਕ ਬੜਾ ਹੀ ਯੂਜ਼ਫੁਲ ਅਤੇ ਇੰਟਰਸਟਿੰਗ ਫੀਨੋਮੀਨਨ ਹੈ। ਇੰਡਕਸ਼ਨ ਨੂੰ ਪਾਵਰ ਜਨਰੇਸ਼ਨ ਅਤੇ ਪਾਵਰ ਟਰਾਂਸਮਿਸ਼ਨ ਆਦਿ ਲਈ ਉਪਯੋਗ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਇਲੈਕਟ੍ਰਿਕ ਪਾਵਰ ਜਨਰੇਸ਼ਨ ਲਈ ਇਹ ਕਿਵੇਂ ਕੰਮ ਕਰਦਾ ਹੈ, ਇਹ ਜਾਣਨਾ ਸਾਡੇ ਲਈ ਲਾਭਦਾਇਕ ਹੋਵੇਗਾ। ਇਲੈਕਟ੍ਰਿਕ ਪਾਵਰ ਜਨਰੇਸ਼ਨ ਵਾਸਤੇ ਵਰਤੀ ਜਾਣ ਵਾਲੀ ਡਿਵਾਈਸ ਨੂੰ ਇਲੈਕਟ੍ਰਿਕ ਜਨਰੇਟਰ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਇਸ ਪਾਠ ਵਿੱਚ ਅਸੀਂ ਜਨਰੇਟਰਸ, ਉਸ ਦੇ ਟਾਈਪਸ ਅਤੇ ਵਰਕਿੰਗ ਬਾਰੇ ਸਟੱਡੀ ਕਰਾਂਗੇ। ਆਓ ਅਸੀਂ ਜਾਣੀਏ ਕਿ ਜਨਰੇਟਰ ਹੈ ਕੀ ਅਤੇ ਇਸ ਦੇ ਸਹੀ ਮਾਇਨੇ ਕੀ ਹਨ। An alternating current generator or electric generator or dynamo is a device which converts mechanical energy into electrical energy. यानी जनरेटर एक मशीन है जो कि मैकेनिकल एनर्जी ਨੂੰ ਇਲੈਕਟ੍ਰੀਕਲ એનર્ਜੀ ਵਿੱਚ ਬਦਲਦੀ ਹੈ। ਕਿਤੇ ਇਸ ਦੇ ਨਾਂ ਵਿੱਚ ਜਨਰੇਟਰ ਸ਼ਬਦ ਨਾਲ ਕਨਫਿਊਜ਼ ਨਾ ਹੋ ਜਾਣਾ। ਇਹ ਜਨਰੇਟ ਕੁਝ ਨਹੀਂ ਕਰਦਾ, ਸਿਰਫ ਮੈਕੈਨੀਕਲ એનર્ਜੀ ਨੂੰ ਇਲੈਕਟ੍ਰੀਕਲ એનર્ਜੀ ਵਿੱਚ ਬਦਲਦਾ ਹੀ ਹੈ। ਜਨਰੇਟਰਸ ਨੂੰ ਇਹਨਾਂ ਤੋਂ ਪੈਦਾ ਹੋ ਰਹੇ ਇਲੈਕਟ੍ਰਿਕ ਕਰੰਟ ਦੇ ਨੇਚਰ ਦੇ ਆਧਾਰ ਤੇ ਦੋ ਕੈਟਾਗਰੀਜ਼ ਵਿੱਚ ਵੰਡਿਆ ਜਾ ਸਕਦਾ ਹੈ। ਇੱਕ ਆਲਟਰਨੇਟਿੰਗ ਕਰੰਟ ਜਾਂ AC ਜਨਰੇਟਰ ਅਤੇ ਦੂਜਾ ਡਾਇਰੈਕਟ ਕਰੰਟ ਜਾਂ DC ਜਨਰੇਟਰ। ਦੋਨੋਂ ਕਿਸਮਾਂ ਦੇ ਜਨਰੇਟਰਸ ਇੱਕੋ ਬੇਸਿਕ ਪ੍ਰਿੰਸੀਪਲ ਦੇ ਅਨੁਸਾਰ ਕੰਮ ਕਰਦੇ ਹਨ, ਹਾਲਾਂਕਿ ਦੋਨਾਂ ਦੀ ਬਣਾਵਟ ਅਲੱਗ-ਅਲੱਗ ਹੁੰਦੀ ਹੈ। ਅੱਜ ਦਾ ਪਾਠ AC ਜਨਰੇਟਰਸ ਉੱਤੇ ਆਧਾਰਿਤ ਹੈ। ਆਓ ਪਹਿਲਾਂ ਜਾਣੀਏ AC ਜਨਰੇਟਰਸ ਦੀ ਸ਼ੁਰੂਆਤ ਕਿਸ ਤਰ੍ਹਾਂ ਹੋਈ। A Danish physicist, Hans Christian Ørsted, in 1820 discovered that an electric current created a magnetic field around it. After him, a French physicist, André-Marie Ampère, found that a coil of wire with current running through it behaved just like a magnet. Finally, English physicist Michael Faraday in 1831 discovered the scientific principle on which generators operate. He reversed the process used by Ørsted and extended the work of Ampere and found that if a current passes through a coiled wire, it could produce a magnetic field. The produced magnetic field could induce or generate a current of electricity in a coil of wire. He also found that by moving a magnet back and forth in or near a coil of wire, an electrical current without any other source of voltage was produced in the wire. However, an American physicist, Nikola Tesla, was the first ever to build the first working alternating current generator in 1892. Thus, the principle on which the working of an alternating current generator is based upon is electromagnetic induction. As a crux, when a coil is rotated about an axis perpendicular to the direction of uniform magnetic field, an induced EMF is produced. Thus, an electrical generator is an important application of the phenomenon of electromagnetic induction. Let us now proceed to understand the construction and working of an AC generator one by one.
It consists of an armature, field magnet, slip rings and carbon brushes. Here, armature is a rectangular coil ABCD consisting of a large number of turns of copper wire wound over a soft iron core. The soft iron core is used to increase the magnetic flux. Here, the field magnet is a strong permanent magnet having concave poles. The armature is rotated between the two poles of a magnet so that the axis of the armature is perpendicular to the magnetic field lines. Here, slip rings are the leads from the arms of the armature connected to the two rings R1 and R2 separately. These rings help to provide movable contacts. As the armature and hence the leads rotate, the rings R1 and R2 also rotate about the central axis. Here, brushes are flexible carbon pieces B1 and B2, which are used to pass on the current from armature to the slip rings across which the external load resistance R is connected. As the slip rings rotate, the brushes provide movable contact by keeping themselves pressed against the rings.
Faraday found that whether the coil rotates within the magnetic field or the magnetic field rotates around the coil, the effect remains the same. The important factor is that the wire and the magnetic field should be in relative motion with each other. Generally, most of the AC generators have a stationary or fixed magnetic field and a coil is made to rotate in this field. It is worth mentioning that the working of an AC generator can be well understood with the help of Fleming's right-hand rule. Also, one should keep in mind that Fleming's left-hand rule is not applicable for electric generators. Anyway, hope you all remember Fleming's right-hand rule. If not, let me remind you of it. Fleming's right-hand rule states that if the thumb, forefinger and the central finger of the right hand are stretched perpendicular to each other in such a way that the forefinger points in the direction of the field, the thumb in the direction of the motion of the conductor, then the induced current flows in the direction of the central finger. Now, let's understand the working of AC generators based on this rule. ਤੁਸੀਂ ਜਾਣ ਗਏ ਹੋ ਕਿ ਇਲੈਕਟ੍ਰੀਕਲ ਜਨਰੇਟਰ ਕਿਵੇਂ ਬਣਦਾ ਹੈ। ਆਓ ਹੁਣ ਵੇਖੀਏ ਕਿ ਆਲਟਰਨੇਟਿੰਗ ਕਰੰਟ ਜਨਰੇਟਰ ਕੰਮ ਕਿਵੇਂ ਕਰੇਗਾ। ਇਸ ਐਨੀਮੇਸ਼ਨ ਨੂੰ ਧਿਆਨ ਨਾਲ ਵੇਖੋ।
Initially, At time t equal to 0, the armature ABCD is vertical with arm AB up and CD down. During the motion of armature between t equal to 0 to capital T by 2, the arm AB moves down and CD moves up. The application of Fleming's right-hand rule tells that the current in the armature will flow in the direction DCBA, means that from the end B to A in arm AB and the end D to C in arm CD. On the other hand, during the motion of armature between T equal to capital T by 2 to capital T, the motion of the two arms is just opposite to that what happens during T equal to 0 to capital T by 2, means that the arm AB moves up and CD moves down. Therefore, during this interval, the current in the armature will flow in the direction ABCD.
As you just saw, a magnet creates magnetic lines of force and a metal coil is made to rotate in it. As the metal coil passes through the magnetic field in a generator, a changing electrical power is produced continuously. At first, the generated electric current moves in one direction, say from left to the right. When the coil reaches a position where it is parallel to the magnetic lines of force, no current is produced at all. As the coil continues to rotate, it cuts through magnetic lines of force in the opposite direction, and the electrical current generated travels in the opposite direction, say from right to left. The ends of the coil are attached to metal slip rings that collect the electrical current. Each slip ring, in turn, is attached to a metal brush which transfers the current to an external circuit. Thus, a spinning coil in a fixed magnetic field will produce an alternating current which travels first in one direction and then in the opposite. To be able to achieve a full command on the working of an AC generator, we should be able to compute the magnitude of induced EMF.
Here, the armature ABCD is rotating in clockwise direction. There is a moment when the armature is vertical or is perpendicular to the magnetic lines of force. So, here the arms AB and CD of the armature momentarily move parallel to the field. So, during this moment, a constant number of magnetic lines of forces is passing through the armature and the rate of change of magnetic flux is 0.
Thus, as d phi by dt is equal to 0, the induced EMF E is equal to minus d phi by dt corresponding to the vertical positions of the armature is also 0. So, at time t equal to 0, capital T by 2 and capital T, the armature momentarily moves parallel to the field and therefore the induced EMF produced is 0. Now, while the armature is horizontal, the arms AB and CD move normally to the direction of magnetic field lines and hence they cut or intercept the magnetic field lines with maximum speed. As a result, the rate of change of magnetic flux is fastest or maximum consequent to the horizontal positions. Therefore, at times t equal to capital T by 4 and 3 capital T by 4, the induced EMF produced is maximum. Now, during a complete rotation of the armature, the EMF which is across the load resistance R changes. The instantaneous EMF developed across R can be given by the expression E equal to E naught sine omega t. Let me now show you the mathematical deduction of this expression you have got for the instantaneous EMF developed across R. Consider a generator of n turns and placed in a uniform magnetic field B, such that its axis of rotation is perpendicular to the direction of the field. To start with t equal to 0, the coil is vertical with arm AB up and CD down. Or you can say that its plane makes an angle theta with the vertical. If omega is the uniform angular speed of the coil, then theta is equal to omega into t. In the position of the coil, the component of the field normal to the plane of the coil is B cos theta. If A is the area of the coil and N the number of turns in the coil, then magnetic flux linked with the coil in this position is given by phi equal to N B cos theta into A, which is also equal to NBA cos theta. Now, substituting the value of theta equal to omega t, we get phi is equal to NBA cos omega t as equation 1. The number of turns in the coil directly affect the magnetic flux linked with the coil. That is, larger the number of turns, greater is the magnetic flux linked with the coil. If the number of turns is n, the magnetic flux linked with the coil increases to n times. Differentiating both sides of the equation 1 with respect to time t, we get d phi by dt is equal to d by dt of NBA cos omega t, which is equal to NBA into d by dt of cos omega t. On simplifying this equation, we get d phi by dt equal to NBA into minus sine omega t into omega, which is equal to minus NBA omega into sine omega t. If small e be the instantaneous induced EMF produced in the coil, then E is equal to minus d phi by dt, which is equal to minus of minus NBA omega sine omega t. Thus, on simplification, we get small e equal to NBA omega sine omega t. This is the equation for the instantaneous induced EMF produced in the coil. It can be concluded that NBA omega is the maximum value of the EMF, say E naught. Therefore, the instantaneous induced EMF becomes equal to E naught sine omega t. Thus, the induced EMF produced is a function of time, and therefore, as the coil passes through different positions with the passage of time, EMF produced changes with time. The EMF would be 0 for omega t equal to 0. When the coil is vertical, positive maximum for omega t is equal to pi by 2, or when the coil is horizontal. It is 0 for omega t equal to pi, or when the coil is vertical. The coil becomes horizontal again for omega t is equal to 3 pi by 2, and the EMF would be negative maximum. It will be 0 again for omega t equal to 2 pi when the coil is vertical and returns to its initial position. Thus, graphically, the EMF varies with time. So, that is it with the theoretical part of AC generators. To be able to have a practical knowledge of making or using them, we need to master some calculations related to AC generators. Let me solve some numerical problems for you before the completion of this class. The first problem is, Sukhbir pedals a stationary bicycle, the pedals of which are attached to a 200-turn coil of area 0.5 meter square. The coil rotates at 2 revolutions per second and it is placed in a uniform magnetic field of 0.02 Tesla perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? For the solution, here the magnetic field B is equal to 0.02 Tesla, number of turns in the coil N is equal to 200 and area of the coil A is equal to 0.5 square meter. Frequency of rotation of the coil is nu equal to 2 per second. Here the angular velocity of the coil is given as omega equal to 2 pi by capital T, which is equal to 2 pi nu. Substituting the value of frequency, we get the angular velocity of the coil as omega equal to 2 pi into 2, which is equal to 4 pi per second. The formula to be used for the maximum voltage generated in the coil is E0 equal to NBA omega. Now, substituting the values of N, B, A and omega in the formula, we get E0 equal to 200 into 0.02 into 0.5 into 4 pi, which becomes equal to 8 into 3.14 volts. Simplifying this, we have the maximum voltage as E0 equal to 25.12 volts. Look at this problem. Paramjeet pedals a stationary bicycle, the pedals of which are attached to a 400-turn coil of area 0.8 square meter. The coil rotates at 4 revolutions per second and is placed in a uniform magnetic field of 0.5 Tesla, perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? For the solution, here the magnetic field B is equal to 0.5 Tesla. Number of turns N is equal to 400 and the area of the coil A is equal to 0.8 square meter. Frequency of rotation of the coil is nu equal to number of revolutions per second or 4 per second. The angular velocity of the coil is omega equal to 2 pi by capital T or 2 pi nu. Substituting the value of frequency, we get the angular velocity of the coil as omega equal to 2 pi into 4, which is equal to 8 pi per second. The formula to be used for maximum voltage generated in the coil is E0 equal to NBA into omega. Substituting the values of N, B, A and omega in the formula, we get E0 equal to 400 into 0.5 into 0.8 into 8 pi, which becomes equal to 1280 into 3.14. Multiplying the two numbers, we get maximum voltage as E0 equal to 4019.2 volts. Another problem is a rectangular coil of dimensions 0.20 meter into 0.50 meter is consisting of 5000 turns, rotates about an axis parallel to its long side, making 2100 revolutions per minute in a field of 0.5 Tesla. What is the maximum EMF induced in the coil? Also, find the instantaneous EMF when the coil is at 45 degree to the field. For the solution, here the magnetic field B is equal to 0.5 Tesla, N is equal to 5000 and area of the coil A is equal to 0.2 meter into 0.5 meter, which is equal to 0.1 square meter. Here the angular velocity of the coil is omega equal to 2100 revolutions per minute, which is equal to 2 pi into 2100 by 60 equal to 22 by 7 into 70 radian per second, or omega is equal to 220 radians per second. The formula used for maximum EMF induced in the coil is E naught equal to NBA omega. Substituting the values of N, B, A and omega in this formula, we get E naught is equal to 5000 into 0.5 into 0.1 into 220, which turns out to be equal to 55,000 volts. When it makes an angle omega t with the vertical, the EMF induced in the coil is given by E equal to E naught sin omega t. Here, the angle which the coil makes with the vertical is omega t equal to 90 degree minus 45 degree or equal to 45 degree. Substituting the values of E naught and omega t in the equation for induced EMF, we get degree E is equal to 55,000 into sin 45, which is equal to 55,000 into 1 by root 2. Simplifying this, we get E equal to 55,000 by 1.414 equal to 38,896.74 volts. There's one more problem. A flat coil of 400 turns of area 40 square centimeter rotates in a uniform magnetic field of 0.10 Weber per meter square at an angular speed of 200 radian per second. The coil has a resistance of 4 ohms. The induced EMF is applied to an external resistance of 8 ohms. Calculate the peak current through the resistance. For the solution, here the number of turns of the coil N is equal to 400, area of the coil A is equal to 40 square centimeter, which is equal to 0.004 square meter. Magnetic field B is equal to 0.14 Weber per square meter and the angular velocity omega is equal to 200 radian per second. Now E naught is equal to NBA omega. Substituting the values of N, B, A and omega in the formula, we get E naught is equal to 400 into 0.14 into 0.004 into 200, which is equal to 44.8 volts. Also, resistance of the coil R is equal to 4 ohms and the external resistance RL is equal to 8 ohms. The peak current through the external resistance can be calculated using the Ohm's law as I naught equal to E naught by R plus RL. Substituting the values of E naught, R and RL in the equation, we get I naught as equal to 44.8 by 4 plus 8, which is equal to 44.8 divided by 12 equal to 3.73 amperes. I feel we have covered the required portions of understanding about AC generators. Let us now summarize once again what we have learned so far before I ask you some questions regarding the topic. An electrical generator is a device that transforms mechanical energy into electrical energy. The working of an AC generator is based on electromagnetic induction. The principle of working of AC generators is that when a coil is rotated about an axis perpendicular to the direction of uniform magnetic field, an induced EMF is produced. During a complete rotation of the armature, a variable EMF is developed across the load resistance. The instantaneous EMF is given by the expression E equal to E naught sin omega t. The induced EMF produced is maximum when the magnetic field lines are parallel to its plane. The induced EMF produced is zero or minimum when the magnetic field lines are parallel to the plane of the coil. This happens because near this position, the rate of intercepting the field lines is practically zero. We now come to the end of today's topic, AC generator. Here's a quick question answer session for you just to find out how much have you actually absorbed. The first question is, who discovered the scientific principle of the working of AC generators? The answer is, it was Michael Faraday who discovered the principle of working of AC generators in 1831. The next question is, what is an AC generator? The answer is, an AC generator is a device that converts mechanical energy into electrical energy. Next question is, what is the principle of working of an AC generator? The answer to this question is, the working of an AC generator is based on electromagnetic induction. When a coil is rotated about an axis perpendicular to the direction of uniform magnetic field, an induced EMF is produced. There's another question, what do you understand by armature? The answer, the armature is a rectangular coil consisting of a large number of turns of copper wire wound over a soft iron core. ਮੈਨੂੰ ਪੂਰੀ ਉਮੀਦ ਹੈ ਕਿ ਤੁਸੀਂ ਲੈਸਨ ਨੂੰ ਸਮਝਣ ਦੇ ਨਾਲ-ਨਾਲ ਇਸ ਨੂੰ ਐਂਜੋਏ ਵੀ ਕੀਤਾ ਹੋਵੇਗਾ। ਲੈਸਨ ਤੇ ਧਿਆਨ ਦੇਣ ਲਈ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। ਅਗਲੀ ਕਲਾਸ ਵਿੱਚ ਫਿਰ ਮਿਲਾਂਗੇ, ਤਦ ਤੱਕ ਲਈ ਆਲ ਦ ਬੈਸਟ।